Welcome to The Explainer. Today we're breaking down a major leap in how AI understands language, and really all of the world's information. We're talking about Gemini embeddings.
Okay, so let's just dive right in with a fundamental question. How do we teach computers not just to read words, but to actually grasp their meaning, their context, and their relationships to other words?
Well, the answer lies in this really powerful concept that acts like a universal map for language itself.
And that concept is called text embedding. At its core, it's a technique that translates text into coordinates on a map. So words and sentences that have similar meanings get placed close to each other, while different concepts, they get placed far apart.
So how does this map work? It represents text using what are called dense vectors. The best way to think about these? They're basically GPS coordinates for meaning. Similar ideas get coordinates that are really close together, and this allows an AI to navigate meaning, not just words.
Okay, so with that idea of a map of meaning in our heads, let's look at the new state-of-the-art model that has basically redrawn this map with incredible precision.
This new model from Google is called Gemini Embedding, and it's not just a small update. Its power comes directly from its foundation. It's built right on top of Google's most capable and generalist large language model, Gemini. And this really shows you the core difference, right? While older models were often trained from scratch for specific jobs, Gemini Embedding gets a massive head start. It's initialized directly from the base Gemini model, which means it starts its life already possessing Gemini's huge knowledge of the world.
So how did they actually build this thing? Well, it turns out the secret sauce is this really clever multi-stage training process.
The team used a 4-step recipe. First, they start with that massive Gemini foundation. Then they pre-fine-tune it on over 1 billion text pairs to get it ready for these embedding tasks. After that, they refine it even more on super high-quality specialized data. And finally, they get to this really cool step called model soup.
Now, what's so fascinating is how they made sure that training data was top-notch. The team actually used Gemini to act as its own quality inspector. Think about that. It generated new training examples for itself, it filtered out the junk, and it even found what they call hard negatives, these really tricky examples that teach the model crucial subtle differences.
And they wrap it all up with that clever technique, model soup. They took several different fine-tuned versions of the model, each one an expert in its own way, and just averaged their parameters together. What you get is this single, more robust, and way more generalized supermodel.
Okay, a great recipe is one thing, but the proof is in the pudding, right? How does this thing actually perform out in the wild?
Well, the ultimate test is this massive benchmark called MMTEB. You can seriously think of it as the Olympics for text embedding models. It tests them on over 100 different tasks across more than 250 languages. It's the real deal.
And the result? A mean score improvement of 5.09 points over the next best model. Now you have to understand, in this field, progress is usually measured in tiny fractions of a point. So 5.09, that is a massive leap forward.
And you can really see what that number means right here. Look at that gap between Gemini Embedding's performance and the next best competitor. It's not just a little bit better. It has set a completely new bar for what state-of-the-art looks like.
But beyond the scores, let's see its cross-lingual power in action, because this is where the magic really happens. Here's the task. We're going to ask a question in Assamese, a relatively low-resource language, and see if it can find the answer in a huge sea of English documents.
An older but still very capable model gets confused. It picks up on a few key words, sure, but ultimately it retrieves a passage about a totally different city and a completely different river. It just missed the context.
But Gemini Embedding? It perfectly understands the intent of the Assamese query. It navigates the English documents and pulls out the exact passage with the correct answer, the Indus River. I mean, this is that universal map of meaning in action, right there.
This is all incredibly impressive from a technical point of view, but what does a better embedding model actually mean for you, for developers, for businesses, and eventually for all of us?
Well, at the end of the day, this breakthrough enhances a huge range of applications we use every single day, making them smarter. We're talking about much more relevant search results, spam filters that actually work, and chatbots that are far more accurate and helpful because they can understand your question no matter how you phrase it.
And that leaves us with this final, really powerful thought. This model sets a brand new standard for understanding text, but the same principles are now being applied to create a single, unified map of meaning for all types of information. So if AI can now understand the world's text with this level of nuance, what happens when it can map images, video, and audio with that same incredible understanding all at once?